Okay, so this is going to be our homework that's was due today, which is 3-4 for honors. I want to be crystal clear about one thing. I haven't looked at these problems other than when I assigned them, so you're kind of going to get like a really super genuine look at how I'm going to solve these because I haven't solved them yet and I haven't really looked too far into them. So we're going to start on 513 with number 15, and in these ones, we're just matching, okay. But, so I should have given you this whole section, but it really comes down to simplifying. So number 15, we got cosine of x times 1 plus tangent square root of x. So obviously the first thing I'm going to see is this 1 plus tangent square root of x. I know I'm going to use a trig function. So let's think of what that might be. So sine squared plus cosine squared is equal to 1. I want to get a tangent here, so I need a sine over cosine. So I'm going to divide everything by cosine. Sine divided by cosine is that tangent squared that we want. Cosine divided by cosine is 1. And then 1 divided by cosine is secant square root of x. So this 1 plus tangent is now going to turn into cosine times secant squared, and I know that this is just going to end up equaling secant, because this is going to be cosine of x, which, no, that's squared, so this is going to be cosine over 1, because I'm going to take away this cosine and away this power. This is going to equal secant of x. Is that one of our answers? Yes, so this one is F. For 17, we have secant squared of x minus 1 over sine squared of x. So once again, I see that we got our trig function that we could definitely use. We got something squared and a 1. That will equal tangent. So tangent squared of x over sine of x. If I take this and go sine squared of x over cosine squared of x over sine squared of x over 1. I like putting this bottom part over 1 just to help me think about it. Because then when you're multiplying by the reciprocal, you have two things on your left side and two things on your right. So sine squared of x over cosine squared of x times the reciprocal of 1. So this is what we're looking at. We're just going to be canceling out these signs, and we'll get secant squared of x, which I believe was an answer. So this one is E. Whoops! Let's not go on Twitter. I'm going to hit my eraser up there. I got a Twitter notification. Alright. So that's those two. Let's look at what we got next. 22. So 22, we are simplifying. We have sine squared x secant squared x minus sine squared x. So I have two different terms, but I have a sign in each term. And I know if I pull out a sign, I'm going to be left with a secant squared minus 1. So secant squared of x and secant squared of, I said secant, I meant sine here, sorry. So sine squared of x, secant minus 1, and we know from this problem that secant squared of x is tangent. So this should be sine squared x times tangent squared x. I'm looking at this and thinking if there's any other way this could simplify, because I know tangent is sine over cosine, so that's not going to go down anymore. Let's make sure the problem's set up correctly. I would go ahead and make a guess that this is probably the simplest. I might just take gander at what the actual answer is. Let's see what the back of the book says for number 22. But this looks right to me. I don't see anything off the top of the dome that I can do here. We're in section 1, page 513 on question 22. Nope, we're good. So this doesn't simplify anymore. This is all good. We just use our trig sub here, or Pythagorean trig identity here. Once again, I'm just going to highlight that in green. And then what we did here is I see a sine squared x here and a sine squared x here, so I factor it out there. What do we got next? 23. 23 is that what we're doing? Yeah, 23. So secant squared of x minus 1 over secant x minus 1. So secant of x minus 1. So I know, you might be tempted to look at this and do a trig sub. Substitute some trig in there. But at this case, I see secant minus 1 in the bottom, and secant minus 1 in the top. And I know the top is going to be a difference of squares. So I'm going to go ahead and expand that difference of squares out, as opposed to using a trig sub here. So I get the secants cancel out, and we're left with a secant of x plus 1. Get all these Twitter for notifications. What's going on? That's alright. 45? Nope, 43. See if these get any more fun. 43. So this is going to look quite a bit like stuff we did in class the past 2 days, especially number 40. Well, I guess both of them. So 1 over 1 plus. This is going to look like our warm-up from Friday. And I don't think too many people had issues here. So if you did have issues, I would pay attention to how this is going to be done. So once again, we're only simplifying here. We're not verifying. So we don't have anything that's equal to. So to simplify this, I have two terms. You probably want to get it down to 1. So to do that, I'm going to find or multiply to get a common denominator. So 1 minus cosine of x, 1 minus cosine of x. Then over here, 1 plus cosine of x, 1 plus cosine of x. Alright, so in the bottom, we're going to have difference of squares. So I'm just going to skip a step. This is minus cosine squared of x. In the top, we're going to get, oh geez, what are we going to get? Oh, let's write it all out. Why not? Oh, yeah, because our cosines are going to cancel out here, so let's just cancel them out. In the bottom, we have something that we're going to use a trig sub for. If we go up top, we want to get 1 minus cosine. So we're going to subtract this cosine over here and get that that's equal to sine. So sine squared x over, 2. Because we got 1. So that's going to be over 2, and this is going to equal to 2 cosecant squared of x. So this is pretty much the opposite of what we just did in class. I think we had just sines on the bottom here and here, because our final answer for that question was 2, what was it? It was 2 secant. So now 45 just takes it up a notch. We got cosine x. Is this the question we did in class? Maybe. Who knows? We're doing it again. And then we are subtracting on this side. Same thing, we're going to find a common denominator. 1 plus sine x. 1 plus sine x. Over here, 1 minus sine x. 1 minus sine x. difference of squares on the bottom again, so we're going to get 1 minus sine squared. This is going to be slightly longer than the last one. So let's make sure we have enough space. So we're going to get cosine of x. Oh no, because no, they won't cancel out. Okay, so this one's going to get a little bit more interesting. Let me make sure I have the problem copied down right. Okay, I do. So cosine minus sine x cosine x. We have a negative cosine, so we're going to get negative cosine x. And then negative sine x cosine x. Okay, let's look at what cancels out, because I'm not entirely sure what we're going to do here. Let's give it a little gander. Oh, I know what's going to happen. Okay. So we're going to get negative sine x cosine x. We're going to have two of them, so it's going to be 2 sine x cosine x. Okay, I was really confused as to what was going to go on, but I really like how this cancels out. So this is going to be a trig identity once again. Let's highlight that in green so we know that that's what we're looking at. I almost clicked I did click my Twitter notification talking about Ukraine. I'm lost. Cosine squared of x is what that becomes. We got cosine at the bottom, cosine at the top, so one of them is going to go away. 2 sine x over cosine x is equal to negative 2 tangent of x. That looks right to me. Sounds right. I actually really like this problem. I like how this cancels out. Who knows? I might even use it on a test. Wink face or winky face. We'll see if I remember to put something like that back on it. But I do like that one. Okay. I digress. What are we doing now? We have, this is on, now starting 520. We're starting with 43. 43, oh, it's an error analysis. Okay, so this is going to be really hard to do over the iPad. Well, actually, no, it's not. I can just write down what our student wrote down. So this is what our student has. So this is probably, no, this is cotangent, excuse me. So this is probably like the question, and it says to simplify, and our student gets cotangent x plus cotangent x, and then 2 cotangent x. And the issue here is that, let's go in red, that this does not simplify to cotangent of x. This is going to become negative cotangent of x because cotangent like of negative x. This is, whoa, this is odd. So you're gonna get the f of negative, whoa, f of negative x is equal to, nope, negative f of x. So that's what I'm getting there. What's next? 45? Yeah, 45. Come on, give me something more fun. Nope, we don't want to have fun today, apparently. 1 plus cotangent squared x times cosine squared x is equal to cotangent squared of x. Alright, so I'm going to try to think of a different way to think about this problem. So I have a cosine squared on the left, and I know that cotangent is cosine squared over sine squared. So I already have, like look at this. I already have this cosine here, and it's on, the top. I got rid of it this time. Go me. So now, somehow, I need to get a sine in the bottom. The only way to get a sine in the bottom that I'm thinking of is cosecant. And look what we have here. We have a beautiful trig sub that is going to straight up equal cosecant. I don't think I wrote this one out. But if we divide all this by sine, we'll get this cotangent squared x equals cosecant squared of x. And if you guys are not understanding how to get these three, I would really highly suggest looking into just some more videos about that, just Pythagorean trig substitutions. I know we've been over the dividing everything by sine and cosine in class. I know we've talked about stuff, but if my explanation doesn't resonate with you, I would suggest the organic chemic tutor. What word just came out of my mouth? The organic chemistry tutor is really good. Khan Academy is really good. What's this other guy's name? I think his name is Jimmy something. YouTube. Let me look really quick, because I think this would be worth it. Jimmy Choo. Jimmy Choo? No, come on, what's his name? Math Pythagorean theorem. Where is he? This guy's awesome, and I love him. He's like my favorite guy. And he makes a lot of like good videos talking about I don't know, a lot of important math topics. Oh, there it is. Eddie Wu. I said Jimmy Choo and Eddie Wu. So let's write those down. The Chem Tutor Eddie. Let's make sure I'm spelling his name right. Wu. This guy is my favorite. Khan Academy, and let me find. There's one other guy that I like who does good work. Sorry, I should have came prepared for this. But alas, I didn't. So leave me alone. It's Friday. All right, whatever. I give up. These three will get you a good start. Let's finish out. We only have one problem left. I probably should have finished the problems and then went on a rant. What is our last problem that we have for today? 49. Oh, I didn't even finish this. But this is cosecant squared x cosine x, which then is equal to cosine squared x over sine squared x because of what cosecant is, which is equal to that. Great. 49. Now this is what we're talking about now. This looks more fun. Okay, so we have 1 plus cosine x over sine x is equal to sine x over 1 minus cosine x. All right, so we're verifying. So we're not allowed to alter both sides and just multiply, this over or divide by sine or anything. So we got to work with each side individually. We need to come to the same answer. So my first thought in doing this is that both the bottoms and the tops are different. So if I get both of the bottoms to be the same, we'll be well on our way. So I'm going to multiply this side by sine x over sine x, and this side. Oh, I already see how this problem's working out. This is going to be so cool. Well, we're actually about to be done. This is actually cool. I like this. Now, look at what we got here. I'm not even going to simplify the bottom. There's no point. We're going to get sine squared of x, 1 minus cosine x times sine x. And then the same thing over here, 1 minus cosine of x. sine of x. And then this right here is the difference of squares. So we're going to get 1 minus cosine squared of x, which is our Pythagorean trig identity, which will equal sine squared of x. And because I'm lazy and through the power of magic, we get that. So at this point, we're done. We got the left side is equal to the right side through only working with the left side and only working with the right side. The one thing here is that I did find out what to make the common denominator, like multiply by, from the left side, but it doesn't matter because all I'm multiplying this by, like this sine over sine is equal to 1, so it doesn't matter that I multiply that in there. I could multiply 876 over 876 and it would still be the same exact problem. It don't matter. So, at the end of the day, if you guys are watching all the way to this point of the video, I'm just going to tell you right now that I'm going to find a problem like this one, because I kind of like this. I don't know if there's more in the book, but I like that one. I quite like this one. If you guys made it to this point in the video, or if you've been watching in the first place, like, go you probably got a little head start on what the test is going to be. So, with that being said, I hope you guys have a wonderful weekend, or if you're watching this on Monday after school or to study, I hope you have a good rest of your day. Just remember that all these sort of things I haven't looked at, and I'm just using the strategies that I've talked about in class to simplify things down to their lowest degree. I thought it would be better if I kind of organically looked through a lot of what's going on rather than having the work right next to me and then working through it just a second time so you could hear my thought process out loud.